So first I'm going to give you an introduction problem, and we actually will solve this next Tuesday. But I want to first give this, talk about this example, and you will see why are we solving it. Okay, so first thing we're going to do, so this is a complete problem. Different from the problems that I did before over here, it's not really complete problem. It's just a phrase. I want you to train you to translate from English to mathematical symbols. But now we have a complete problem. So you will be able to find out what that x is or what that y is. So a number times 5 plus 7 is 2. Find that number. It's not really a very complicated question. And I know many of you probably can already tell what the answer is without using any algebra x or y. So, but why do we still want you to use algebra or equations specifically to solve this problem? Because right now I cannot give you a very complicated problem and trying to teach you how to use algebra to solve it, because it's going to be just too hard. So all I can give you is a simple problem. Even though you may be able to get the answer without using algebra, I still want you to use algebra to solve the problems. Why? Because I want you to learn this technique. So maybe when you have a complicated problems, you will be able to use this technique. Okay, use algebra to solve it. So what we do is find the number. The first thing you want to do is to look at what the problem is looking for. What are you solving for? So we don't know what this number is, so let's call it x. So let's just call it x. If you want any letter you want to use, A or B, and then we're gonna translate this sentence into mathematical symbols. Okay. I don't know if anybody, you may have learned this before, or so what we do is do what we just did, what we just practiced. When you see a number, this is the number we're looking for. We already use x. We decided to use x to represent that. So let's just put x for that number there. And the times, just multiplication. So we're going to use times. And a 5 would just be symbol 5. Plus would just be plus. 7 would be 7. Is. So what? This is something new. So what is the mathematical symbol for is? Does that matter?
Equal sign.
Yes, very good. Thanks. Is that a Bailey? Yeah, so we're going to use the equal sign. And previously, we never had an equal sign. That's because we did not have a complete sentence. It's just a phrase. It's part of the sentence. So we never had a complete sentence. Now we have a complete sentence. So when you see is, it means equal sign. Okay, sometimes they just say equals. And of course, that's the equal sign. And you bring down that 2. So now look, we got, this is something what we call an equation. Previously, all the practice questions we did, we can call these algebraic expression. Just have 4 plus x, it's expression. But now we have an equal sign in there, and there's a left-hand side and right-hand side. So that's why we call this kind of expression, we call them equation. Okay, let me put them closer, these two, x times 5. Like I said, we like to put numbers in front of x, and we omit that multiplication sign and just simplify the writing. So we end up with 5x plus 7 equals 2. So this is what we call equation. And we need to solve for x. So we need to do some work to find out what x is. Okay. All right. But because this one involves actually 2 steps, so we want to start with 1 step. And then next Tuesday, we will learn how to solve equation like that. So again, some of you, I think some of you may have already learned how to solve equations like this. All right. So today, I just want to start with 1-step equations. And next week, we have 2 steps, 3 steps, 4 steps. Okay. So the main goal is whenever you have equation, there's unknown in there. Your goal is to solve for x equals something, or in other words, to get, so our goal is to get x by itself. So we got to remember that. So every step we're doing is towards that goal. to get x by itself. So because right now when you look at the x, it's mixed with 5 and there's a 7 right behind it, and we eventually want to just get a single letter x on one side. It could be left or right, and everything else should be moved to the right. Okay, so it's really a lot of moving, but we have to follow certain operations. So the first thing we're going to look at is these 4 operations you are allowed to do. Okay, if anybody's going to take high level math like calculus or anything, you will learn more operations that you could do. But right now we only gonna use one of these 4 operations. Okay, so I'm gonna explain these operations a little quick. So when you look at the equation, it also has something equals something. So what's the equation? You have a left-hand side equals a right-hand side. In this example, I have 5x plus 7. That's my left-hand side. On the right-hand side, I have just a single number 2. It could be complicated. Okay, but it doesn't matter what they are equal. If they are equal, you can think of this as a balanced scale. So I have a left-hand side and right-hand side, and they are equal to each other. And when they are both positive, we can think of them as a balanced scale. In this example, so I can describe it as, okay, left-hand side, we have 5x plus 7. Right-hand side, we have a 2 there, so 2 pounds maybe. X is, you can think of this as an unknown box. So I can just put a box right here, say, okay, this is like a box, a black box. You don't know what's in there. You don't know how heavy it is, right? But everything else you know. Okay, so there's a 5, this box, the weight, we're gonna multiply by 5 times 5, and then we add another 7 pounds to it, and you get a number 2 there. Okay, so you can kind of think that way. So to do this kind of question, we could, again, is to everything, we want to move everything to the other side, the 7 and the 5. So we end up with only the unknown box, the black box there. So what can we do? Now I'm going to start with a simple example. Suppose we have an equation, which is x minus 2 equals, let's say 5. So now this time the left-hand side has x minus 2. The right-hand side has a 5. So what we could do is, in order to get x by itself, I could add 2 pounds. It's like saying, if I take, say you have a box, unknown box, many pounds there. If I take away 2 pounds, say take 1 pound, take 2 pounds. After I take away 2 pounds, I would end up with 5 pounds. That's what it says. Okay. So what we could do is we can put that 2 pound back. We can add 2 pounds to both sides. And because we want to keep the scale balanced. Why? Because if the scale is balanced, you can still use an equal sign. If one side is heavier, the other side is lighter, say I put 7 pounds here, but I put 5 pounds here, and then it's going to be tilted, and 5 is not going to be equal to 7, and 5 is less than 7, right? So in order to find out, because the answer should be x equals something, so you always want to keep the equal sign. And how do we keep the equal sign? Then you have to make sure the scale is always balanced, whatever you do. How do you keep it balanced? Say I add 2 pounds to the left, and also I'm going to add 2 pounds to the right. If you have already, at the beginning, you have a balanced scale, and you add the same amount of weight to both sides, it's still going to be balanced. But after we add that 2 pounds back, so the 2 shaded boxes in black, I'm sorry, in green, if we add that back, okay, so we kind of like took it away. Let me do this. So you can think of the problem like this. So we have like boxes with, I don't know how heavy that is, how heavy it is, the weight. But what we're gonna do is, let's add a, 2. Okay, so this after we take away these 2 pounds, so if I take that away, we are going to get 5 pounds there. After we take it away, so which is represented by x minus 2. x. So this much is x minus 2. But if you want to find out x, which is the original without taking away those 2 pounds there, all you have to do is to add the 2 pounds back. So we're going to add 2 pounds, the 2 shaded 2 pounds back. And then the right-hand side, we get 7 pounds. And that left-hand side will be the original x. Okay, so this is the original x. The black boxes are x minus 2. So if we added 2 pounds back, you go back to the original. So that tells us x equals 7 because it's balanced. Okay, so this is an example to explain why we could do that. So a lot of you may already know, okay, when you see that, okay, we should add 2 to both sides. But why? Why do we do that? Okay, it's because you want to get rid of the minus 2. You want to put that 2 pounds that you took away back. You add it back. So when you add the 2 pounds back, you go back to the original x, the original box. Okay, so after you add, then you will go back to x, and the right-hand side you will get 7. So that's why the answer is x equals 7. The original will be 7 pounds. And one thing we need to remember is, whatever you do to one side, you must do the exact same thing to the other side. See, what I did here was adding 2 pounds to the left to make up that 2 pounds, cancel the 2 pounds we took away. And you also have to add 2 pounds to the right-hand side. If you don't, it's not going to be balanced anymore. So you added 2 pounds to the left without adding anything to the right, it's going to tilt because the left side will be heavier. Okay. So what we need to, I highlighted the both sides. But it's right now it seems very obvious, but later when you have a complicated equation, you may forget that's something we have to do. Look, the left-hand side, that's what I did. Right-hand side, I did. So you always want to double check. Did I do exactly the same thing to both sides? So I'm going to draw a line to separate the left and right, the left-hand side and right-hand side. And you can see the left-hand side, what's the operation I did? Plus 2, I added 2. The right-hand side, I added 2. So which is a legal operation, okay? All right. So next Tuesday, I will show you example, a common mistake that I saw students make. They didn't really understand why it's wrong, okay? It seemed to be right. It's very tricky. But if you remember this rule that I said, whatever you do, make sure the operation you do on the left matches the operation you do on the right. You will understand why that operation is incorrect. Okay, so I'm going to give you another example. So this explains why we could add a same number to both sides. If I had x plus 2 equals 5, and you in order to get rid of that 2 pounds, so you just take away that 2 pounds, right? So you have an unknown box here. You don't know how heavy that is. But after you added 2 pounds to it, you found out, so this is original x, and that is x plus 2 because you added 2 pounds there. And after you added 2 pounds, the scale tells you, hey, that's 5 pounds equals 5 pounds, right? So in order to the unknown box x, this is the unknown box x, you just have to take away that 2 pounds that you put in there. So you would delete, take this away, take that away. But if you take these two away without doing anything to the right, it's going to tilt because the left-hand side is going to be lighter, right? So you could also take 2 pounds away from the right-hand side. That will still keep it balanced. Subtract the 2 here, subtract 2 there. Okay, so that's what we're going to do. And they cancel each other because that 2 pounds you added had been taken away. So you end up with x on the left, and the right-hand side, we get 3. Okay, so we can subtract the same number from both sides. Similarly, we could also multiply. So if we have a division, x divided by 2 equals 5. So this time what we do is if you have unknown box and you can cut the box in half, you take half of it away. After you take half of it away, maybe I should redraw this. Okay, so this piece. So this is the original x. But after you take half of it away, okay, cut the weight in half, and then you end up with 5 pounds equals 5 pounds. So x divided by 2 equals 5. So we actually have to take that away. But what we're looking for is the original, right? So in order to do that, you just have to double it, because you cut it in half, you double it, and the operation of doubling is multiply by 2. So what we could do is you take what's left, which is this, times by 2, both sides, and we'll still keep it a balance. So that would go back to, after you time both sides by 2, you would add that half back. And the way it works algebraically, so that what you do is use what we learned about fractions. So you will put 2 over 1 under here, underneath. If you remember what we talked about, was that Tuesday or? Well, last week we also talked about, in homework 2. So you can multiply straight across. So you're going to have 2x over 1 times 2. And then you simplify it. That's something I noticed some of the students forgot to simplify your answer. Okay, so make sure your fraction is always reduced. So the top 2 can cancel the bottom 2. So we end up with the x divided by 1. X divided by 1, we know that's one of the properties I think we talked about. Any number divided by 1 is always itself, so which is x. You don't have to show all of that. You could just put x down here equals 10. Okay, so if we add that back, you're going to go back to that x, which is equal to 10 now. Okay, so we can multiply both sides by the same number, any number, 2 or 5, anything. So the last case would be if I have x times 2 equals 5, or 2 times x equals 5, either way, I can move 2. Usually we like to put 2 in front of the variable. So that means I have an unknown box x, but if I double it, I put another one with exactly the same size or the weight, and so that's already doubled. After doubling it, we get 5 pounds here. So 5 pounds, that's balanced now, equal, right? So in order to find out the unknown, the original x, we only need that. So we're going to have to get rid of that doubled weight by dividing by 2 both sides. So 2 divided by 2, we get x equals 5/2. Okay. Now, I do notice in the past that some students got confused by number 2 and number 4. For number 2, we have to do subtraction. Number 4, we have to do division. And I noticed in the past, some students thought they could just subtract a 2 from both sides to get rid of that 2 there. No, unfortunately, this is incorrect, okay? And we also talked about this, yeah, I think it was just a Tuesday, right? This will not work. Why not? Why not? Because 2x minus 2, we cannot subtract them. Because there's x in here, but this one doesn't have x. So 2x minus 2 is not going to give you x. It's not equal to x. You cannot subtract a 2 from 2x because you don't really know what that x is. That x could be 2 apples. And then you subtract the $2. It doesn't make any sense, right? You cannot do that. And that x really could be anything. So it's not going to give us x back, okay? When do you get 1x? If you have 2x minus 1x, yeah, that give you have 2 copies of x, you take away 1 copy of x, yeah, you'll get a 1x, right? But if you have 2x and you subtract a 2, you can't do that. You cannot subtract them, okay? So I want to point this out. So make sure you understand the difference between 2 and a 4. A good tip is say, okay, well, well, it looks like, how do I know when to add, when to subtract, and when to multiply, and when to divide? If you look at the examples that I gave you, you're always trying to reverse the operation, right? So if I have like a subtraction here, how you do you reverse subtraction? You do addition. If I have addition here, plus, how do you reverse a plus? You do minus. And if I have this line means division, right? You can do multiplication to reverse the operation. And I had multiplication, you can do division to reverse that operation. So that's a quick tip for you. So in order to get rid of, because our goal, what's our goal? Get x by itself. Get x by itself. So if you have something other than x, you have to get rid of it. But how do you get rid of it? Okay, do what we call inverse operation or opposite, kind of like opposite. So if you have plus, I'm going to do minus. If you have minus, I do plus. If you have so if you have division, I do multiplication. If you have multiplication, I do division. Okay, so this is the first rule. You don't always have to do this, but this works most of the time. Okay, so that's the first rule. Always do the opposite operation to try to reverse it. Okay, questions? So